Jupiter's moon Io is a fascinating world with a violent and dynamic landscape. One of the most remarkable features of Io is the presence of active volcanoes. The first evidence of volcanic activity on Io was discovered by the Voyager 1 spacecraft in 1979. Since then, subsequent missions have confirmed the presence of numerous active volcanoes on the Moon. The volcanoes on Io are some of the most active in the solar system, with some eruptions reaching heights of up to 300 kilometers. The eruptions are powered by the tidal forces exerted by Jupiter's gravity on Io's interior, which generate heat and create the conditions for volcanic activity. Io's interior is composed of rock and metal, with a molten layer beneath its crust. This molten layer is subject to intense tidal forces from Jupiter, which cause the rock to flex and heat up, creating pockets of magma that rise to the surface and erupt as volcanoes. The volcanic eruptions on Io are not like those on Earth. Instead of spewing molten rock, they emit a mixture of sulfur dioxide gas and sulfur particles, which freeze in the cold vacuum of space to form colorful plumes and deposits on the surface. The volcanic activity on Io has created a landscape unlike any other in the solar system. The Moon is covered in dark, volcanic plains and dotted with bright spots where fresh eruptions have occurred. Some of the larger volcanoes on Io have calderas that are tens of kilometers across, making them some of the largest volcanic features in the solar system. The Great Red Spot is a giant anticyclone, or high-pressure system, that is twice the size of Earth. It spins counterclockwise and has wind speeds of up to 400 miles per hour. The Great Red Spot was first observed by telescopes on Earth in the 17th century. In the 1970s, the Voyager spacecraft made the first close-up observations of the storm, revealing its intricate structure and dynamics. Jupiter's atmosphere is made up mostly of hydrogen and helium, with small amounts of other gases such as methane and ammonia. The Great Red Spot is believed to be a high-pressure region within this atmosphere, with gases flowing in and out of the storm. The formation of the Great Red Spot is still not fully understood. Some scientists believe that it may be the result of interactions between the planet's atmosphere and its magnetic field. In 2016, NASA's Juno spacecraft arrived at Jupiter and began a series of close flybys of the planet. These flybys have provided new insights into the structure and dynamics of the Great Red Spot, as well as other storms on Jupiter. The Great Red Spot is a stunning example of the power and complexity of the storms that can occur in our solar system. By studying these storms, scientists hope to better understand the dynamics of planetary atmospheres and the forces that shape our solar system. The Great Red Spot will continue to be a focus of scientific study for years to come, as we seek to unlock the secrets of this fascinating storm. Saturn is one of the most spectacular and recognizable planets in our solar system. One of its most distinctive features is its system of rings, which are made up of countless individual particles. The discovery of Saturn's rings is credited to the astronomer Galileo, who first observed them through a telescope in 1610. However, it wasn't until the Voyager 1 spacecraft arrived at Saturn in 1980 that we gained a detailed understanding of the ring's structure and composition. Voyager 1 was launched by NASA in 1977 and embarked on a mission to study the outer planets of our solar system. In November 1980, it made its closest approach to Saturn, passing within 124,000 kilometers of the planet's cloud tops. During its flyby, Voyager 1 made a number of groundbreaking discoveries about Saturn's rings. It identified several new rings, including the F ring, which has a complex structure with several distinct strands. Voyager 1 also found that the rings are made up of countless individual particles, ranging in size from tiny dust grains to boulders several meters across. These particles are thought to be the debris left over from the formation of Saturn and its moons. One of the most stunning discoveries made by Voyager 1 was the sheer beauty of the rings themselves. The A ring, in particular, is known for its bright and intricate patterns, which are created by gravitational interactions with nearby moons. Voyager 1's mission to Saturn was a landmark achievement in space exploration. Its discoveries have provided us with a wealth of information about the structure and composition of the rings, and have deepened our understanding of the formation and evolution of the planets in our solar system. Saturn's moon Titan is one of the most intriguing destinations in our solar system. It is the only moon with a dense atmosphere, and its surface is shrouded in a thick orange haze. In 1980, NASA's Voyager 1 spacecraft made a historic flyby of Titan, coming within 6,490 kilometers of its surface. During this encounter, Voyager 1 made a number of groundbreaking discoveries about Titan's atmosphere. Voyager 1 found that Titan's atmosphere is made up primarily of nitrogen, with smaller amounts of methane and other gases. The atmosphere is so dense that it creates a pressure at the surface that is about 50% greater than Earth's. The atmosphere of Titan is also unique in that it contains organic compounds, including hydrocarbons and nitrogen compounds, which are thought to be the building blocks of life. In 2005, the European Space Agency's Huygens probe landed on Titan's surface, providing us with the first direct measurements of the atmosphere and surface of the Moon. The probe found that the surface is covered in lakes and seas of liquid methane and ethane. The discovery of organic compounds in Titan's atmosphere has led to speculation that the Moon could potentially support life, although the extreme cold and lack of sunlight on the surface make this unlikely. Voyager 1's mission to Titan was a landmark achievement in space exploration, and its discoveries have deepened our understanding of the complex and dynamic systems at work in our solar system. NASA's Voyager 1 spacecraft, which was launched in 1977, has played a critical role in our understanding of cosmic rays. Voyager 1 has been traveling through space for more than 40 years, and in August 2012, it became the first spacecraft to cross the boundary of our solar system and enter interstellar space. One of the key instruments on Voyager 1 is its cosmic ray detector, which measures the intensity and energy of cosmic rays as the spacecraft travels through space. Cosmic rays are typically made up of protons and other atomic nuclei, as well as electrons and other subatomic particles. Voyager 1's cosmic ray detector has provided us with important insights into the properties of cosmic rays. It has shown us that cosmic rays become more intense as we move further away from the Sun, indicating that they are likely coming from beyond our solar system. Scientists believe that most cosmic rays originate from supernovae, which are powerful explosions that occur when stars die. Voyager 1's mission to study cosmic rays has been instrumental in advancing our understanding of the universe and the forces that shape it. As Voyager 1 continues to travel through interstellar space, it will continue to provide us with valuable insights into the properties and origins of cosmic rays, helping us to unlock the mysteries of the universe.